I am Anil Kumar. Welcome to my series on trigonometry. We are taking some extended exam review questions. Here we have a right oblique triangle. I am Anil Kumar. Welcome to my series on trigonometry. In this video, we'll discuss another excellent question which I'll categorize as the extended exam review questions for oblique triangles. The question here is, in the triangle ABC, ED and BF are perpendicular to AC. As you can see, ED and BF are perpendicular to AC. You need to find, and also FE is perpendicular to AB. So FE is also perpendicular to AB. Find the length of DE in terms of angle A. That's what you have. We are given four choices. D is equal to one of these. You can pause the video, answer the question, and then look into my suggestions. Now we want the value of DE. Let's try to understand. So what we're trying to figure out is what is DE, which is this particular side. So if you look at it, this side could be related with the angle right here. Now whenever you have combination of right triangles, then the triangles could be similar. And therefore, you have to look for the cases that which angles are equal, right? So let's look into the angle which is equal to A so that we can really relate this particular side DE with AB, which is that side, right? So we are trying to relate this with AB. So if you look at it from here in big triangle, angle F is 90 degrees, and so we can always find AB in terms of this particular angle. The opposite to A is side FB. So we can say that FB over the side AB is equal to, since this is opposite to that side, sine of angle A. In terms of FB, FB is equal to AB sine of A. Now in every option which we do have the term AB sine of A, right? That's a common term. That probably gives us some hint. So FB we have related to AB sine A for us. Now how can we move forward? We have to actually find DE. That means to find DE, we have to check the two triangles right there. So let's look into the angle part first. So if this angle is angle A, in that case, the angle here will be what? The angle here will be 90 degrees minus angle A. Now, in the bigger triangle also, this one, which is AFE, that angle should be equal to angle A, right? So we have the triangle which is AFE, in which the angle DEF should be equal to angle A, right? So we have this thing. Now If I consider the next triangle, which is also a part of 90 degrees triangle, we can say that now if this is angle A, that is 90 degrees, then this angle here is what? This is 90 minus A. Perfect. Therefore, we get the other angle which is right there also as equal to angle A. So what we figure out is that these three angles are equal to angle A. So that should help us to solve this particular question. Does make sense to you, right? So let's have a good look at it. What we're trying to say here is that this angle A is also equal to the other two angles which I have marked. So that's a key. In any combination of 90 degrees with common bases or one of the sides which is kind of linked with them, you will always find that they are similar triangles. Because one angle is 90 degrees, the other one is 90 minus theta, and so you get your answer. Perfect. Now, so with these two things, let's move forward and continue solution to our question. So what we figured out is, let's move ahead in a fresh page, that this angle here is equal to that angle and this. So these angles are all angle A, right? So what we have here is that angle A is also equal to angle DEF, which is also equal to the angle EFB. Perfect. We also found a relation that FB is equal to, FB is opposite to A in the bigger triangle, and FB is equal to AB sine A. Right. Now, let's consider the smaller triangle and have a look at the triangle FEB. In triangle FEB, how could we relate FE? Now, FE is on the adjacent side of angle A, right? So FE is adjacent, so it is cosine of FB. So we can write FE is equal to FB cos A. But FB is AB sine A, so we could write this as AB sine A cos A. Is that clear to you? So we have got FE now, which is this side. Now let's find the actual side required, which is DE. So if I go to the triangle, which is the smaller one, DEF, in that case, this is angle A we're talking about, and hypotenuse now is FE, and that becomes the adjacent side. That means the cosine relation. So DE is equal to FE cos of angle A. But FE is AB sine A cos A. So we'll replace this. So we get AB sine A cos A times this cos A. And we get our result, which is, let's write down our result here, which is AB sine A cos square A. Perfect. So AB sine A cos square A is option C for us. So that becomes the solution of this particular question. So I hope the steps are absolutely clear. Correct? So what we did was, we did it in two parts. In part 1, we identified the angles which are equal to angle A because of the 90 degrees triangles. And then we related one by one the sides with angle A and got a result. Perfect. As seen here. So I hope the steps are absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.